I've got this going and working. So let's go straight into it. Algebra 1 students, it is me, Mr. Swearingen. Here, starting off our first video notes with Unit 7, 7.1. This whole unit, we're talking all about exponents. So I guess let me say, today we will be able to define exponents, and we'll be able to calculate exponents of zeros and negative exponents. So an exponent is just this. If I have a variable, a number or something, and then I have something in the top right corner, this is what our exponent is. What that means is if I have that same thing, the actual number or variable, that's what our base is. So if you see something that looks like this, the base is the bigger number, the exponent is the thing in the top right. What does an exponent do to its base? Well, if we see something like 2 to the third, what we're seeing is 2 times 2 times 2. That's what this means. We multiply the base by the number in the exponent. Yes. Every base has an exponent. So even if I give you a number, let's just say this. If I just give you this number 4, although we don't see an exponent here, there is an invisible exponent. When we don't see it, that invisible exponent is just 1. So when we don't see it, it is 1. Let's get some practice with actually seeing what exponents do to numbers. So here we have 7 squared. So what that's saying is I'm doing 7 times 7. I'm taking my base and I'm multiplying that number 2 times because 2 is my exponent. 7 times 7 is 49. Four to the third, well, now our exponent is 3, so I'm taking 4 times 4 times 4. I'm doing that 3 times. Here you can type it into a calculator. I'm going to do it in my head real quick. 4 times 4 is 16. 16 times 4 would give us 64. Once again, you can do that in a calculator. No big deal. In example 3, we have exponents. We still think about it in the same way. So x squared, the math that we're doing, is x times x. Now, in the other problems, we've been able to multiply it, like 7 times 7 is 49, 4 times 4 times 4 is 64. When we have exponents, well, we don't actually know what the number is. So the most simplified we can get is that x squared. There we go, that's our intro, that's our warm-up. Now let's move on to this zero exponent property. See here, it says a to the 0 equals 1. Well, the zero exponent property says whenever our exponent is 0, our answer will always be 1. No matter what number or variable you have for your base. So here, as soon as we see that 0 in the exponent, we just know our answer is 1. Here, as soon as we see 0 in our exponent, same thing, 1. These are kind of nice. Okay, here we go. So anything to the power of 0 equals 1. That's 0 exponents. The other thing we're doing today is talking about negative exponents. So if you have a negative exponent in the numerator, the base and its exponent will move to the denominator, and the exponent becomes positive. What that's saying, first of all, in a fraction, we have our numerator on top, our denominator on the bottom. So here where we have this a to the negative m equals 1 over a to the positive m. Let's remember, whenever I see any number or variable that's not in a fraction, we can always make it a fraction over 1. Now, do you see how we have a negative exponent in the numerator? To fix that, all we have to do is we take the base, we take the exponent, we move it from that top to the bottom. We move it from the numerator to the denominator, and it becomes positive. Let's get some practice with that. So, example 6, we see x to the negative third. Well, I'm going to go ahead, and what I want you to do is see this as a fraction, because that's going to help us a ton here. Here we are seeing x to the negative 3 over 1. Well, does x have a negative exponent? Yes. So to fix that, see how it's starting in the top of our fraction. See how this x starts in the top? Because it's negative, we want to move it to the bottom. When we do that, we get to change our exponent to be positive. The interesting thing that's happening in example 7 is this. A lot of you are going to want to say, oh, the answer should be this. Because we have this negative exponent, we want to move this whole thing to the bottom. And that's some really good thinking. However, we actually want to take this base by base. So here, remember how we said if there's a base with no exponent, it's going to be 1? This thing right up top and the top right. Well, here we're going to do that with this 3. Let's go ahead and put a 1 next to that 3. Now, for our answer, let's draw our fraction line and figure out where they want to go. When I look at 3 to the power of 1, is that exponent positive? Yes, 1 is a positive number. Because it's positive, I don't have to move it. So I can keep it in the top. When I look at x to the negative fifth, does that have a negative exponent? Yes, negative 5 is negative. So negative tells us we should move. So it started in the top, I move it to the bottom, I make that exponent positive. So this would be your answer. Or you could then ooh, shoot, didn't want to erase that whole thing. Then you could just write it without the 1 for the 3. We're moving on to negative exponents from the denominator, but it's very similar. If you have a negative exponent in the denominator, the base and its exponent, wow, I'm fumbling over my words. The base and the exponent move to the numerator, and the exponent becomes positive. So really what's happening, we're doing the same exact process, but the negative starts in the bottom. See here? A to the negative m starts in the bottom. We hate having negative exponents, so we just move it to the top. And that's how we get that positive m. Let's do some examples. Here we see our negative exponent. That tells us we want to move it from the bottom to the top. We just flip where it is. When we flip, the exponent becomes positive. So you could just leave your, wow, that is, I don't know why it's so sloppy there. Your answer could be x to the third, or if you had it as x to the third over 1, if you still had it in that fraction, that's good. You would just then simplify that to just be x to the third. Example 9 is another case where we have two bases. So see where I have this x? I'm going to go ahead and put a 1 for its exponent, just so we can see what's happening. And then I'm going to go ahead and draw my fraction bar. When I look at x to the exponent of 1, do I need to move it? No. Because it's positive, I don't need to move it. So I keep it where it is. When I see y to the negative 5, do I need to move it? Yes. Because this negative 5 is negative, I need to move it to the top and make it positive. Here we really don't need that fraction bar because we have nothing there. We could put that as 1, but then let's simplify that to x times y to the fifth. Now we got a couple examples, 1, 2, 3, 4, 5 examples to move through. You know what? It's probably a good idea. So pause the video, try 10, and then we'll work through it. Here we go. I'm going to go ahead and put 1s next to each of those bases. I see this negative 3. So I'm still going to have 4 times 2 in the top, but I'm going to have x to the third is going to end up in the bottom. So that's going to end up being 4 times 2 is 8 over x to the third. If we have numbers, so here, if we have numbers, we do want to simplify our answer. So here I took that 4 and 2 and I made it 8. We want to simplify that. Go ahead and do the same thing for 11. Take a bit, look at it yourselves, see what that will become. Here we go. If it's helpful, I'll go ahead and write it. If we have 3b to the negative 2, we can write that as a fraction, as over 1. Let's go base by base. So my base of 3 has a positive exponent, so it'll stay on the top. My b base has a negative exponent, so it moves to the bottom. The exponent becomes positive. And that's all in this one. Example 12, we have some new stuff going on. Excuse me. So, x to the negative third, and our answer, well, we see that negative exponent, so we'll move it to the bottom. Then I see this a to the 0. Well, a to the 0 just cancels out to be 1. Remember, I'll zoom up real quick. Let's remember anything that has an exponent of 0 will always be 1. So it kind of just disappears here. But if you wanted, you could write times 1. Y to the 5th, well, it's already a positive exponent, so I can just keep it where it is. See here how we have nothing on top of our fraction bar? If there's nothing in that space, we'll just put a 1. So our answer, when we simplify, will be x to the 3rd, y to the 5th. Example 3, take a moment, pause. Here we go. 3 to the 0 just becomes 1. X to the 4th, do we need to move it? Nope. X to the 4th will stay. And then we go ahead and simplify out those numbers. So this is x to the 4th. That's 2 times 2, which is just 4. So when I simplify this, it's just going to be 4x to the 4th. Finally, how can I get this to see it better? There we go. We have 14. X to the 4th, does it stay or does it move? X to the 4th stays. 5 to the negative 2, stay or move. This one moves from the bottom to the top. And then y to the 0 power, well, that just becomes our 1. So remember to simplify here. Our answer is going to end up being 25x to the 4th. Because we need to remember, we see that 5 squared, we need to do that math. We need to multiply that out. Okay, there we go. That is our guided notes for 7.1. So, you have the practice worksheet to do on your own. Happy mathing, and let me try to remember how to